Okay, let's go to the third and last step in this circuit building. What we will do in this step is connect this servo motor. So this little component that you can see here, this will allow us to perform movement with our circuits. So we are going to connect these to this board. But for this one, we're going to use a different approach for connecting it. So I wanted to show you this in a video and do this together with you before you are off and doing your own thing with it. Let me show you the stage that I am in now. So in the previous video, we basically built a circuit to be able to read light with one light sensor. And then what I did in the meantime is just I replicated it two more times. So what we see here is what I did in the first video, just done 3 times. So it results, as you can see, in a bit of a mess of wires, but I'll put this a little bit aside so that you can see, hopefully. And what we have here is the 3 light sensors with the 3 resistors. Out of each one of these sets, 3 wires come out, 1 positive, 1 negative, 1 signal. So we should have a total of 9 wires coming out of this setup. As you can see, the wires are a bit flimsy, and because there is so much slack, sometimes they become accidentally disconnected. When we are working on the table, it's it's a pity, but this is what you have. So try to make sure that the connections are kind of sticking in, and try not to move it so much if possible. And then from this setup replicated 3 times, we still are drawing the power and ground from these other 2 pins that go directly to the board. Now, the thing that is different about this little gadget, about this servo motor, is that this servo motor runs on 5 volts. So if we give it only 3.3 volts, it will not have enough power to be able to move around. So we need 5 volts for that. I will show you in the schematic what I mean. So this is the scenario that we have now with the 3 light sensors. And this is the scenario that we are going to build next. As you can see, this ground and power wire, they're coming from ground and 3 volts respectively, and I drive them to one of the rails. So the ground rail is blue and the 3.3 volt rail is red. What I'm going to do is to get another red wire coming out of the 5 volt or USB pin in our board, and I'm going to send that one to the other red rail. So we are going to have one red rail, in this case the upper red rail, that is 5 volts, and the lower red rail, which is 3.3 volts. Now when we work with this is something that the ESP32, the HUSA, the board that we are using requires. Arduino normally works on 5 volts only, so you don't have to worry about any of these different voltages. But more sophisticated boards and more recent electronics work on 3.3 volts, not on 5. So it's not completely a useless exercise, because you will see that a lot of the more modern prototyping boards have this make this distinction between 5 volts and 3.3 volts. So what we're going to do next will hopefully be a skill that you get to practice quite a bit when you are working with more recent boards. Right, so without further ado, I'll just go and connect the thing. The first thing, of course, before I mess with the wires, is I'm going to disconnect a USB to make sure that should any shorts happen, whoops, that went away, should any shorts happen, that I don't blow up my electronics before the time has come. And then I have here another servo. This one is prepared, and what I decided to do is when you get the servo clean from the bag, you see that it has this connector. All right. And this connector is a hole through connector, so it has holes. It doesn't have pins, so that means we cannot really connect it to our board just yet. So what I tend to do is I use 3 of these cables, 3 of these wires, and stick them in like this, and that will get you a connection of sorts. So I have one prepared here. So these 3. The thing that you have to keep in mind is that the red wire is always plus. In this case, the brown wire is minus, so I connected it to a black one. That's kind of like the convention for minus and ground. And then the yellow is the signal, so that's the way that the microcontroller will tell this little motor how many degrees to turn and in which direction. So I already prepared 3 wires to extend this, and what I'm going to do is just connect them to the locations where they need to be. Let me move this a little bit further down so that you can hopefully see. Let's see. Yeah. So again, black to ground. I'm going to use the upper rail, and as you can see, the upper rail still has nothing on it. There's nothing connected to it. I will do that next. I will drive 2 wires from here to the upper rail to get the right power and the 5 volts. Then I have so my signal is going to be blue, and then I have my plus, which is gray in this case. Well, I recommend that you use red or orange for plus because it can get pretty confusing very quickly. And then my my blue is going to be my signal, and in this case we just need an analog pin. Now in the schematic that I shared with you, the analog pin, it's there. Let me make this window a little bigger so that you get to see the exact, hopefully that will be a bit more clear. So it's connected to that pin. The rare sunshine is occluding my view, so I have to get a bit closer to the monitor. You'll lose my audio for a moment. Yeah, so that's pin 12 in the ESP in the HUSA. And in my case it's in another location because I'm not using the same brand as you, even though they work exactly the same. So I will bring it to a different location, but you just follow the schematic that I shared with you, and that's the most reliable guide. All I want to do is just present to you how this is done in terms of the actual manual labor that goes into this. But for reference, it's best if you use the graphic, because my pin layout is slightly different. And that's it for this specific element. This element is not yet connected though to the board, because we haven't driven our ground and our 5 volts yet to the rails, but we have it connected to the protoboard, to the solderless protoboard. And now what I need to do is get my ground from here somewhere, and I'm going to do that with the green wire, and I have luckily a second ground here. I'm going to drive that to the pin, to the upper pin, sorry, to the upper rail over there, just like that. So hopefully in the ground, getting a second ground to the second rail up here. And the last step to be able to send 5 volts to this thing is that I get 5 volts from my board and get them to these red rail here on top. So if you remember, the red rail at the bottom is 3.3 volts plus, and the rail at the top will be 5 volts plus. The 5 volts you can get from in your HUSA featherboard, you can get them from a pin called USB. It's this pin over here, USB. USB means that the power coming from the USB connector, that's always 5 volts, USB is always 5 volts, is bridged directly to that pin. without being influenced by any other electronics. It's not stepped down or anything. It's just 5 volts coming straight from our USB connector. In my case, it's in a different location because I'm using a similar board, but from a different brand, so the pin layout is slightly different. But I see that over here I have a pin called 5 volts, so I will just let's see if my tweezers cooperate. Yep. So I pull out my 5 volts, and just over here nearby I connect them to my red rail up here. And now, if everything went well, when I power this whole thing, the servo will be powered. Now everything here is really flimsy and unstable at the moment, but then we can use a bit of tape and maybe even hot glue to stick some of these parts around. But while we're working on the table and we are building the code, this is good enough. This setup will be good enough. So I'm going to just connect the USB cable now, and hopefully, if nothing goes up in flames and smoke, it will all be fine. There we go. And that seems all right. So that's step 3. That gives you the entire circuit that we're going to be using for, as let's say, the technical basis for the assignment, for the exercise of this sprint. And yeah, hopefully you got this far, and you can replicate this setup. Otherwise, let's try and all help each other. Some of you have more experience, so please ask around any colleagues that might need help. And yeah, you can always also reach out to me, and we can see what might be going on. But yeah, from the camera, I'm sure that this is quite confusing. The schematic that you have to follow, I suggest you really use the graphic rather than what you see in the video camera. The schematic is probably much more clear, and but I just wanted to do these together with the schematic so that you see things look slightly different in reality always than they do when you draw them in the computer, of course. So I just wanted to show you how you would practically go from schematic to final layout in a video. All right, thanks for watching, and I'll see you in the next one.